record this. All right, so what we're going to do today is first I want to practice graphing circles and limacones. So that's what we did last class and we ran out of time. So I want to make sure everyone knows how to graph them, because we're not going to graph all of the points like we did before, right? We're just going to do like a shortcut method. And then we're going to learn one more curve, which is going to be rose curves. And if we have time, we're going to go over this polars graph concepts review. If not, that's something that you can look at on your own, and the solutions are on Canvas. Okay, so a couple reminders. The homework for this for after today is not so much. So just there's a homework for rose curves, but we're going to have a polars test next week. Okay, so Tuesday we have class and we'll review in class, and then you will be in school next week. So I'd like, if possible, for you to take the test in the testing center after school, and you can do that on Wednesday or Thursday. So you can think about it and then let me know later when you'd like to do that. Okay?
Okay.
If it doesn't work for you after school, then I can set something up on Zoom. Okay? So we'll see what's happening. We're not having a final exam, we're having a final project. And we have class Friday next week. So we'll talk about the project on Friday, okay? And then during review week, we have only one class during which you can work on the final project. The final project, you can work with a partner or on your own. So if you want to think about that too, you know, I just wanted to tell you ahead of time. Okay, so what I really want to do is graph some limacones and circles, okay? So I sent you this warm-up worksheet where we're going to graph 4 of these types of figures. Okay, and my goal is now is for when we look at the equation that we can figure out what type of limacone it is, so that will help us sketch it. You'll notice that the way this worksheet was generated, I used some different software. It's putting where we have here where it says r equals 1 minus 2 cosine theta. We would have written that as -2 cosine theta plus 1. So if you see something that's not written in the same form, you can put it in that form, right? So we had a sine theta plus d, or a cosine theta plus d, right, for the limacones. So if it's the constants first, you can just flip it because addition's commutative, okay? So I want to graph r equals -2 cosine theta plus 1. What I recommend for these is I would make a little sketch of the graph in the Cartesian coordinate plane, okay? And to do that, let's see what the key information is, okay? So if I have -2 cosine theta plus 1, where's the midline?
1.
It's good, it's at y equals 1. And what's the amplitude?
-2.
2, not -2, but 2. Terrific. I'm glad you corrected yourself. And so now let's make a quick sketch. So we're going to put in the midline. So this is 1, 2, 3, 0, -1. So I'll put in the midline. And then from the midline, what do I do to get sort of that skeleton for my sine wave?
Like you put a midline at y equals 3.
Y equals 1. Oh, I put a line at y equals 3, right?
Yeah.
That's going to be our maximum. And then what else do I do?
A minimum at y equals -2.
-1.
Oh, sorry, -1.
Yeah, so it's going to be 1 minus 2, right? We go up 2 and down 2. Now, this is a cosine graph, and it's actually a negative cosine. So we need to know the starting point, right? So cosine, so a negative cosine, where does that graph start? So I want to know
The minimum.
Starts at the minimum. Starting point at minimum. So that's going to be at 0, -1 for this particular graph. And I'm going to sketch it. I'm going to put a scale on my x-axis. We don't have any period change in this cosine graph. So we're going to have a key point every quarter period, which is every pi over 2. Okay, so I'm going to put some tick marks on the x-axis. So I got pi over 2, pi, 3 pi over 2, and 2 pi. And now we're going to sketch the graph. So it starts at the minimum, so at 0, -1. Then a quarter period later at pi over 2, it's going to be at the midline. So pi over 2, 1. So we got 0, -1. Then we have pi over 2, 1. Then at pi, it's going to be up at 3. And then 3 pi over 2, it's going to be back at the midline. And then at 2 pi, it's going to be at the minimum.
Can we not just like say that the absolute value of...
You can do that as well. So we'll talk about both of those.
Okay.
Okay, but I want to make sure everyone understands it. And if that works for you, that's fine.
Okay.
Okay, so what's happening in this graph? We have, the graph is going above and below the x-axis, okay? So it goes above and below the x-axis. When that happens, we know we're going to have a looped limacon. Now, what Janie was saying, you know, can't we just look at the absolute value of A and the absolute value of D? Absolutely, right? So the absolute value of A, in this case, that's like the amplitude, is 2, and the absolute value of D is 1. So in this case, the absolute value of A is greater than the absolute value of D, which will also conclude that it's a loop limacon. So if you can remember that and that makes sense to you, then that's fine. You don't have to make the sketch, although we still need the points to make this, to graph the loop limacon. Okay, so if you don't want to make the sketch, you still have to figure out those points, and you can figure out those points by plugging into the equation. R equals, you know, -2 cosine theta plus 1. Okay, so now we know what we're going to graph, and we have these 4 key points. Okay, so these are the points that we want to graph. We want to get points 1, theta 0, pi over 2 pi, and 3 pi over 2. Okay, and we found those by making the sketch. So if you don't want to sketch it, it's okay, but you still need to find those values. Okay, so whichever way works for you. Okay, so we're going to graph 0, -1. Right, so if we're at 0, -1, that really means that we have to, if we were on 0 with a positive r, we go in the positive direction, right? But if it's a negative r, that means we actually go out towards pi. So we're going to plot that point. Next one we're going to do is pi over 2, 1. So pi over 2, 1. Then we're going to plot pi 3. So 1, 2, 3. And then, oh, I put it at the wrong place. 1, 2, 3. And then we're going to plot 3 pi over 2, 1. And that's all we need. With those 4 points, knowing that it's a looped limacon, we should be able to sketch the graph. Right, so I know that my loop is going to be, this point here is sort of the head of my loop. So it's going to go, let me try to graph that better. We're going to be going something like this, and then this part out here is more like a squash circle.
So on the test, we don't have to do like this is the kind of, this is the way we're gonna have to do it, or is it gonna be like the very specific like point 3?
No, you only need to show these 4 points.
Okay.
Okay, so just show the 4 points on the axes and then the general shape. Yeah, Aria.
Can we show more if it helps us?
Absolutely.
Okay.
Yeah, you can figure out more if that will help you, but it's not necessary. Okay, right? So I mean, we know that this is a loop limacon. I didn't say more about it. We should say that it's I put that down. That it's horizontal, right, and mainly on the left, right? We know all of that because it's a negative cosine. Cosine is going to be horizontal. Negative cosine is mainly on the left. Okay. All right, so let's look at the next one. Okay, so you guys help me on this one. What do we know about, we're going to graph this. This is -2 cosine theta plus 3. That's the way we would think about it. Okay, so who wants to lead the charge for this one?
I can.
Okay, great.
So we can draw like the regular, I forget what it's called, plane?
The Cartesian.
Cartesian, yeah.
Yep.
And the midline is y equals 3.
Good.
And then the amplitude is 2.
Good. So what do I do with the amplitude?
So for the amplitude, you draw a line at y equals 5 and a line at y equals 1.
Nice.
Sorry, I just want to draw it.
Yep. Right, so
Um,
we go up 2 and down 2 from the midline. Perfect.
and then it's cosine, but it's negative. So you want to start at a minimum, which would be 0, 1.
Great.
And so you do, and then we want to label the x-axis with 4 points. So it would be 0, pi over 2, 3 or pi, and then 3 pi over 2,
Uh-huh.
and then 2 pi.
Perfect.
And then you want to just go pi over 2, 3, pi 5.
Yep.
3 pi over 2, 3.
Yep.
2 pi 1, and then
Terrific.
that's all we need. And then you just do it and draw arrows.
Yep.
And then we take those points. So 0, 1 on the circle.
Good. So 0, 1, we plot it.
Pi over 2, 3.
Great.
And 3 pi over 2, or sorry, pi 5.
Pi 5, 1, 2, 3, 4, 5. Yep.
And then 3 pi over 2, 3.
Great. Okay, before we make our sketch, because those are all great, those are all 4 points, what kind of limacon do we have?
Dimpled, I think.
Yeah, it's dimpled limacon. Why is it dimpled?
Because it stays on one side of the x-axis.
Good. So it's
And
only positive in this case.
And also because the absolute value of A is less than D.
Very good. So if that makes sense to you, the absolute value of A is less than D, that means that it's not going to cross the x-axis, which means that we're going to have a dimpled limacon. Yeah, Aria.
If it was all on the negative side,